We are really honored to have with us Massimo Banzi, co-founder of Arduino. And Massimo, I'll let you introduce yourself in the session, but thank you so much for joining us.
All right, so thank you very much. My name is Massimo Banzi. I'm the co-founder of Arduino. And one of the things that I really like tinyML. I'm really fascinated by the possibility of the technology. And also, one of the things I really like is to take technology and make it more available to a lot of people. So one of the things I would really like to see is 1 million new tinyML developers. So how do you build tools that scale to like a very large audience? So what we do in Arduino is we create tools that enable anyone to innovate by making complex technologies simple to use, which is a fairly broad mission, but the idea is there's a lot of these technologies that would really enable people to do amazing work, but a lot of that is in a way represented or designed to be used by a smaller audience of very specialized people, but not every technology is incredibly complex to the point that you cannot try to make it more available. And so the work that we did in the last few years was to try to make microcontrollers more usable by people. And in the process, we learned a number of things that are quite interesting on how there are ways that you can make this kind of technology more accessible to people. So it's going to be the least nerdy talk of the day because we're going to focus mostly on some of the aspects of what it means to work with people that are slightly outside of your very narrow group of specialized people who build the technology. So in a way, Arduino now has an estimated amount, 30 million people around the world who work with the technology at different levels. And the software that we make to program microcontroller is downloaded 41 million times a year. So we have a very, very large community that we build slowly over the years. I'm pretty sure that apart from Visual Studio Code, which is clearly beyond any number you can imagine, 41 million is quite a big number for a development tool. So to do this, we went through a process of trying to figure out how do you make things simple so that you can widen the audience of people who have access to technology. I'm very fascinated by the fact that there are this massive AI system. This is a project that's on a wall on the MoMA. It's the entire map of everything that you need to run Alexa. And so these kind of, big AI systems are fascinating and yet scary. And also it's scary in a way the amount of computing power that you need in order to power these things. And I'm very fascinated by this shift in the computing power, the fact that you can now get a little stamp-sized computer that has an incredible amount of computing power compared to, this is the user interface of the computer that was on the Apollo mission. So if you think about it, the change that was in the last 50, 60 years of the amount of computing that we have now. And so we have computers that are incredibly more powerful. They cost $30 instead of millions, and they consume nothing. So this, to me, this kind of curve, it's very fascinating to me. And I teach. I do a lot of my work apart from working on Arduino is to teach, but most of my students are not engineers. They are designers. They are specifically interaction designers. So they are people who use technology to imagine the products that you will use in the future, but they are not engineers by training. So they use the technology. And so when I started to, in a way, use tinyML with my students, I was trying to highlight some of the values to me that are quite important. Notwithstanding, a lot of people I work with are very, very interested in the topic of privacy. Anyway, one of the interesting things about tinyML, in my opinion, is the fact that we can build some use cases where we can just extract information from things where the data is created and avoid the leaks that can sometimes lead to horrible privacy debacle that sometimes happen when data gets transferred somewhere else without, without any filtering in a way. So to me, the interest in this kind of topic started when we built this project, which was it's a board that we built with Intel. And this board in the Curie chip, there was a piece of hardware that was called the Intel pattern matching engine. It was effectively IP from General Vision, and it was a collection of a number of things they call neurons, but there were sort of 128 individual cells that they could basically build a classifier. So there was a memory. You could store a quote-unquote sample of something in it, and then essentially you could then run and you can then basically ask the system to match whatever data you were feeding to it, and there would be an election system that would decide which one of the neuron was right. So this thing was very interesting because it allowed me to do some classes with my students that we called trainable UIs. I really like the idea that you could build projects that you could train. It's very interesting, the idea that you could build something that as people use it, they kind of learn and they work with you. So I did different classes between 2017 and 2019. Some of the project that came out was, consider that these are students that they study programming for about 2 weeks, then they study electronics for about 2 weeks, and then when we do this thing, we spend like a week and a half. So it's incredible the amount of things that people can learn in a very, very short time if you build the tools for it. So for example, this is a lamp that responds to gestures that can be customized by the user, or this is an alarm clock for people that don't wake up in the morning, so you have to train it with a different kind of combination, quote unquote. So when you wake up in the morning, you have to do the right gestures, otherwise it's not gonna stop. And which is, by the way, in my many years of teaching designers, this seems to be a problem that they always have. This designing things that will make you wake up. So this was another tool. It's a switch with a relay that turns things on and off depending on a sound. So they had it, for example, next to a kettle to turn on things on and off based on the sound of the kettle going off and things like that. So these are simple projects, audio. This is a switch that can learn from audio. This was another interesting project. This is a window that tries to learn when you open the window. What are the conditions around the window when you open it? So that when these conditions find themselves again, the window will open itself automatically. So for example, did you open the window because birds were chirping? So it will learn that. Clearly, it's not an incredibly practical idea, but it's very nice the fact that people think about these kind of things. This is my absolute favorite. So you put this in your house. When your neighbors make a noise, you press the orange button and you train the device on whatever noise your neighbors make that you hate. And this thing will start banging on the wall. So even if you're not at home, extremely useful. So even when you're not at home, it will bang on the wall. So it will train your neighbors. So there's always a learning algorithm involved. And this was another crazy project where this group of students built this. These are essentially robots that move around the house taking care of the plant. So whenever they figure out the plant needs water, they go around until they find a place where there is water, or when they need sunlight or anything. So they try to learn from the plant. It was a very ambitious project. It sort of worked. And this also is another interesting project. It's a knife. that can be trained. So it can be trained by a chef, or it can be trained by, whatever person that knows how to cook. And then while you're cooking, there's like a visualization on the handle that tells you if you're doing the movement right. And so it's interesting because these are all things that the students came up in just a few days as a way to, what if you can apply this technology to, I would say one of the very interesting things about this technology that was very, very limited, the one in the Arduino 101, is that you could train on the device. So that was a quite powerful thing that a lot of tinyML systems don't really have yet, but it's very interesting. So these are some things I learned. They are in a bit of a random order, so there's no, but obviously one of the things that work really, really well, if you have examples that make sense and that can be easily replicated. This seems like an obvious thing, but there are a lot of things that when you try to follow the steps, there are always pieces missing, or I think one of the most painful things trying to replicate some tutorials that have to do with machine learning is that they never work. Because, you need that very specific version of something. So figuring out a way that you can just reproduce steps very simply. So this is the tool I used to learn electronics when I was a child. So you just snap together the blocks and you build the circuit. So there would be these books where you just copy the schematic, the project would work, and then they would explain to you what you just learned. And this process seems simple, but it's not so obvious because in the classic way of teaching technology, you never do this. You just flood the students with a ton of theory, and if they survive, then you let them blink an LED. And, but only if they survive. And the other way is also try to look at the whole experience. No? So in a way, although Arduino is like a simple thing, but in a way, the hardware, the software, the teaching methodology, and the user experience are designed to kind of work all together. And this is, obviously a lot of people are focused on one aspect, or they're focused on extremely detailed aspect of optimizing an algorithm, but everything has to fit together. Otherwise, people will have a lot of trouble using your technology. Also, don't be afraid to illustrate things very simply. So this is from the same book. You can see the electrons are pushing that gate that is essentially a transistor. It was very interesting because when we started working on Arduino, trying to simplify the technology of microcontroller, there was a lot of people that laughed at us. They told us that we were idiots. Somebody described Arduino as a baby talk language for potheads. Because in the mind of some people, if you're a designer, you're clearly an artist, so you're clearly smoking pot. So this was this idea that if you try to simplify technology and you do it for children, it's fine. If you're trying to do it for adults, no, it's bad. You're teaching them wrong, they don't understand. But we shouldn't worry about that. Because our objective, remember, is to get another million people interested in what we do. And also another interesting thing about machine learning when I try to work with my students is that a lot of the material is obviously very advanced math. But it doesn't have to be like that. And also the problem is that a lot of students, or a lot of the people I work with, they don't know this advanced math, so they can't read this. But there's also some interesting things that happen with Arduino. Electronics by itself, it's quite complicated for a beginner. But if you shift as much as possible to software, it's way simpler to teach. So what we did with Arduino is to basically try to capture the data from a sensor and turn it into a number as fast as possible so that you can process it as code. And what this Freya is showing here is how you can turn some of the more that stuff, if you don't know advanced math, those symbols are very difficult to understand, but a for loop is much more understandable. So the shift to code makes everything a lot more simple to explain. And also there is also I'm not the only person who thinks this. So Francois, who is responsible for Keras, is also looking at, the kind of the balance between advanced math and software engineering. Also, it's very interesting because the way you were trained sometimes is an obstacle for you to be able to explain something. So when I went to school, the way I was taught was like, a lot of theoretical lessons, blah, blah, blah. But then I realized that when I learned electronics, I was a child and I was experimenting with things. So when I started teaching, I replicated the same way I was taught at school, and obviously it didn't work. So then I started to teach the way I learned, through experience, through an experiential way of learning, and everyone got involved, everyone got engaged. Also, it's interesting to try to build tools that teach the principles, because obviously, so this little thing, we built it in Costa Rica with children, and it's a simple perceptron that classifies Lego blocks. So whenever you put it on, the algorithm makes a choice, and then you press a button to say to the algorithm, you got it wrong or you got it right. But it's very interesting because with this tool, we were able to take like a 9-10-year-old kids and teach them about perceptrons and learning and training and all these kind of processes, which is kind of interesting. So if you have a way to build this, so you see the child is experimenting. It's also very interesting, I noticed, to figure out ways to show what's going on inside. In a lot of systems, it's very difficult what goes on inside. So for example, this is a KNN classifier that we built as a way to teach people about KNN. But there's an HTML web page outside of the board that visualizes the data as it comes in and tries to build a graph of all the data in space, so that people can learn by looking at the data represented as a graph instead of looking at numbers. Because the numbers on the left don't make any sense. The dots on the right, they give you a clear indication of what you're dealing with. So the user experience is central. So we are used to think the user experience applies only to consumer products, but it is very important because the user is at the center, and the way they perceive the technology they're working with, or the way they respond to that, is something that can be designed, must be designed, and it needs to be. So even tools for developers, sometimes they suck, because there is this idea that if you're a developer, you need to suffer. No, that tools have to be painful because that's your life and whatever. But then whenever someone makes something simple to use, they magically it works, no? So in a way, the way you look at the interfaces, this is just I'm not mentioning any platforms, but it's just an example of how you can use the user experience to make the whole process more understandable. It's interesting also to note that APIs are also a user interface. So the way you design a button on a screen is as important as the way you design APIs. So one of the things that we've done in Arduino for a long time is to really work on the APIs. And it's amazing how you get the API right. The amount of people who can take advantage of a technology just skyrockets. And sometimes people design APIs, again, the way they like the APIs they learned, and they don't realize how much better it would be if there was a really attention to the user. Another thing that's interesting is to build systems that are layered in a way that can be discovered progressively. So for example, when you program with Arduino at the beginning, you are an incredibly high-level system. You build things with like 10 lines of code. Obviously, there is a huge amount of assumption that goes into that way of doing things, but I can teach people in 2 weeks how to build an IoT connected device from scratch. We can build cloud connected devices with people that have no background in electronics in 2 weeks. Obviously, as they progress in their understanding of the technology, your system has to be layered in a way that they can peel back the layers and dig deeper. So in Arduino, everything is open source, so it's all designed in a way that you can peel a layer and go underneath until you reach incredibly low level code that deals with the hardware directly. But people can choose to go down one layer when they are ready to go. Also, be careful not to try to make the magic button. Like you press the button and everything will be okay. Something that completely hides the process from people, that's too much. You want people to be able to discover what's going on underneath. Yes, you can automate, yes, it's great, but then you want people to understand the principle at some point so that they can actually make full use of what you build. So the magic button is not always good. And also it's important to build meaningful real life examples. I say this because a lot of technologies, they have examples that are very dry, very abstract. They don't map to anything in real life. And this obviously makes it harder for people to get engaged. So one of the things that worked really well with Arduino is that people built real life projects that anyone can understand. And that meant that a lot of people that didn't care about embedded development, they wanted to learn because they saw real life things. So I'll show you a couple of interesting examples. So this is a device that when your dog is barking, sort of does something to make them stop barking, which is useful when you're not at home. Or this is a project for detecting the early stages of epilepsy. Again, this stuff was built by people that are not machine learning experts. They're built by people who wanted to solve problems. I mean, this is a project I built to read data off mechanical counters, which is a classical problem that you have in industrial equipment, that there's a lot of data that's on mechanical or not connected devices. And so with that, you snap it on and it works. Or this is interesting. A lot of farmers I spoke to, they told me that they need something like this. This is a trap that detects a specific type of insect and will count the number of insects and send the data to a cloud. There's a lot of areas of the world where when the specific insect shows up, your crop are destroyed or they're about to be destroyed. So this is done, I'll show you later, with something that's the size of a postage stamp and runs on a solar panel this big. But it's whenever I talk to farmers about this, they get it immediately. They're interested about this, and it actually brings some of the people to say, hey, I want to learn how to build this. This is another project built to detect respiratory problems in pigs from sounds, or this is a system that someone built for themselves because they had to do shoulder rehabilitation. So they basically trained this thing to detect the right movement to do on their shoulder. And then they used this to basically help themselves do the right movements. And so it's an interesting project that kind of brings together everything that we kind of, there's 3D printing, tinyML, electronics. It's all done by the person themselves to solve their own problem, which is obviously the peak of usefulness of these technologies. And this is a device that detects the crying of a child so that they combine it with a remote camera so that they can be alerted about that. Sorry, the PowerPoint keeps going by itself. I have to figure out why. But another thing that I realized that if you have powerful building blocks that are immediately useful, people build a lot of very interesting projects. So this is a, oops. So this is the tool we use for the insect trap. So it's a camera, it's basically 23 millimeter in size. It's got a number of sensors, Wi-Fi. It's powered by an STM32 dual core processor and can be programmed in C++ or Python. And it's interesting how I was able to get people to build things with this that have very little experience in ML or electronics, because they have everything on the board. So they really didn't they didn't have to do any electronics. They could just plug the cable and go. So this is a real life example from a company in the northeast of Italy who built this sensor to detect if plastic bottles have a cap mounted on correctly. So this is not an incredibly complex use case. It's actually kind of stupid. But what's interesting about this is that this is people working in a small company in the north of Italy that don't have any experience in machine learning. They don't even have the skills to do machine learning with the tools that are normally available. But they are solving problems because they are expert in making machines. And they are adding these tools because simple tools are available. Or this, for example, is another prototype of a system, again built by a company in the north of Italy, who normally builds automation for car companies, so for car manufacturers. What's interesting about this is, again, the company is full of, I think the oldest kid in the company is 26. So they hire a bunch of people from the technology high schools. And so this is it's a cobot that moves around a car part to check if certain parts that have been manually mounted are correctly fitted. And so they were able to build this in just a few hours because, again, the tools, the way the concepts are explained allows somebody to really apply to a problem they have, which for me is the most important part. So this one is another member of the family that's got sensors on it. One of the funniest thing about this thing is that it's got this gas sensor from Bosch that can be trained. It can run some small machine learning algorithm internally to the sensor, so it can be detected to detect the smell of cheese or coffee, or it detects if a drink has alcohol or not. It's very interesting because this sensor and the capability that come with it, and also Bosch built a tool that allows you to simplify the whole process of training the sensor, is what captures people's attention the most. And it's the same size as the other one. So this one, again, is something that you just plug the cable and it's ready. It's got a bunch of sensors. There's no electronics to be built. One of the interesting things I think about the work that I like to do is to concentrate on the people that are outside of the space where we are. So when we started working on Arduino, since we were developing tools for embedded development, people thought that we were trying to compete with the people that already made tools for embedded developers. But that I didn't really care about that. What I wanted to focus on all the other people and try to get them to be embedded developers. And one of the tricks to get a lot of people involved in doing embedded development was basically not to tell them they were doing embedded development. They were looking at a lot of cool examples. They thought, wow, that's cool, I want to do it too. Oh, what I have to do? Oh, I have to use this thing called Arduino. Okay, cool. And then as they start to become more experts and they start to peel the layers, then they realize they were doing embedded development. So this process is very important. And one other thing that I really like is to engage with people outside your world, to try to always engage with people that are in a different space. So for example, this is a project that we are doing right now. We took that little sensor box, put it in a plastic case with the battery and everything else, and turned it into the zipper of a keyway jacket. So Keyway, it's an Italian/French brand of rain jacket. So we are basically now giving this away to a bunch of people that not necessarily are experts in machine learning to see what we can do with this. So we are starting off with the idea, what can we do if we have all these sensors embedded in a thing that you wear all day? And then we will help them with the technology to implement the code. Again, this is another step. Engage with a community that's different from yours so that you can expand. It's an extension of what I was saying a couple of slides ago. So, in general, one of the things I've noticed is that when people that don't have a lot of experience in a certain technology approach that technology, they see it as a wall that's very difficult to climb. And a bunch of people, they give up. And it's a real pity because there's a lot of intelligent people with a lot of good ideas that they give up because the way we present the technology is too complicated. But in a way, I noticed that what works really well is to try to explain things in a way almost like it was a set of stairs. So you have a number of steps, you go up the steps. So you still climb into the same height, but the idea is that you take one step at a time, it's manageable, it's divided in chunks, and this idea that you can slowly progress to reach the top, it's a very important process because it really brings people to the field. And so the same way we got 40-something million people engaged with embedded development, and I guess of all of those 40 million people, probably 30 don't know that they're doing embedded development. I think we can build tools like this that really bring people to tinyML, which I think it's a very cool topic in technology, very modern. Also because in a way, one of the things I really always like to remember is that a very small group of engineers create technology that shape the entire future of the human experience with incredible speed. This is Jaron Lanier from his book, You're Not a Gadget. And so we have a responsibility as people who build technology for things that then influence the life of real everyday people for a long time. So if we have tools that bring the technology to a large number of people, we will build a world where there are multiple answers to the same questions instead of, being boxed into very few solutions by really big companies that decide what we do. So thank you very much.